Hello everybody. We're going to look at 5.3 again today, and we're going to be factoring trinomials. And remember, these are situations where a equals 1. And so if we have ax squared plus bx plus c, then this will equal 1. And so usually we won't see anything there. So it'll kind of look like this, right? And b and c will be real numbers, usually integers. And so, all right. So if we take a look at number 56 here, this is straight from the book. Then one difference that we see today is that we have a different variable, right? So we're used to seeing the first variable there, but we hadn't seen a second variable with these type of questions yet. All right, but no big deal. We actually do the same thing. Check for GCF first. There are no common factors bigger than 1 here for 56. So then we see, okay, well, is this going to be a perfect square trinomial? And since 12 is not a perfect square, we can't use that type of factoring. So now we're going to resort to our trinomial method. So since we have a y squared here, we're going to put a y here and a y here, because when we FOIL, y times y is y squared. And then we need a t squared here at the end. So the only thing you have to do when you have a second variable is just put that variable in the back, and that's all you have to do. And then the rest is just like we did before. Okay. Now we're going to look for numbers we can multiply to get 12, that we can subtract to get 1, okay? That invisible 1 there. So numbers we can multiply to get 12 that we can subtract to get 1. So if you can't think of them off the top of your head, that's okay. Just make yourself a list of pairs, of factor pairs. So 12 is 1 times 12, 2 times 6, 3 times 4, right? And we know we're done with our list when the next number is already on the other side. Okay, so when the next number is already on the other side, that means your list is done. Okay, because if I put a 4 here, it'd be 3, and so forth and so on. Okay, all right. So do any of these have a difference of 1? Do any of those can I subtract to get 1? And 3 and 4 is right. So I can put a 3 and a 4 in there in front of the t's. Okay, and I can see 3t times 4t is going to be 12t squared. That's good. But I need a negative, right? 12t squared. And remember, this is the sign of the bigger number, so that's going to be a positive. I'm going to put a positive in front of the 4. Okay, and then to get a negative here, our signs have to be different. So that means the 3 has to be different from positive, right? It has to be a negative. And so then you check to see, can we factor any more? Nope, it's not. We don't have any difference of 2 squares or anything like that, and so that's as far as we can go. All right, so it's really the same thing we did before, except for now we have that second variable behind the numbers. Okay, so really no major change there. So let's take a look at number 60. So same idea. There are no common factors to begin with, so we can't factor anything out. Then the next thing we can check for is it a perfect square trinomial? 24 is not a perfect square, so that's not going to work. So then we're just going to set it up, and we're going to say, okay, well, we have an x squared here, so we're going to put an x here, x here. Since we have an s squared here, we're going to put an s here and an s here. And then we want numbers we can multiply to get 24, right, that we can subtract to get 5. So once again, if you might be able to come up with those on top of your head. If not, make yourself a list of factor pairs. So 1, 24. So I just start at 1, and it's always 1 in itself to begin with, right? And then does 2 go in? 24 divided by 2 is 12. Does 3 go in? 24 divided by 3 is 8. Does 4 go in? 24 divided by 4 is 6. Then I get to 5. Does 5 go in? 24 divided by 5 is a decimal, so that doesn't work. And then now I'm back to the other side again. So remember, once you get to the other side, once you get to a number on the other side, that means your list is complete. So these are all the factor pairs of 24. So which one of those can I subtract to get 5? And you guessed it, 3 and 8. So then I'm going to put a 3 and an 8 in there. Okay. All right. Remember, this is the sign of the bigger number. And the second sign tells us, okay, well, if that's negative, that means the signs have to be different, right? Because in order to multiply to get a negative, we have to have a positive times a negative, or a negative times a positive, right? And so remember, if you ever need to check your answer, you can always FOIL this out, right? X times x is x squared. 3s times negative 8s is negative 24s squared. So we're good so far. To check this middle term, that's the one you have to maybe a little more thinking is you would multiply outer times outer. X times negative 8s is negative 8xs, right? And then 3s times x is positive 3xs, right? And then if you combine those like terms together, negative 8 plus 3 is negative 5xs, right? So that's how we get that. All right. So it looks like we got the right answer, and that's how it's done.